Hello everyone, welcome to Sir's classes. This is Tushar Shaw, and in this video we will be continuing to solve the BHU PET 2020, that is the MSc entrance exam after undergraduate level. So we will be continuing to solve this paper. We did up till question number 1. Okay, only one question was there. That was an extremely big question, so we required one video for solving that. So in this video we will be moving on to question number 2. I've already told you about the pattern of this paper. That is, there are 120 questions in this paper. Okay, and all of them would be of MCQ type. Okay, uh, there is negative marking there. That is half mark per wrong question. Okay. So yeah, so this is all about. I have already discussed in details about the question pattern of this paper in the earlier video. So you may go check that video out. Okay. So without wasting any time, let us dig into the questions. So so the second question of this paper says that in which of the following reactions ketone is a substrate. Okay. So So without looking into any other techniques or any other methods of solving this question, we are given four reactions. Four of the name of four reactions are given: pinnacle rearrangement, the Hoffman rearrangement, Wolff rearrangement, and the Baeyer-Williger oxidation. So what we'll be doing is I'll be writing the mechanisms of all four reactions that are there. Okay, and after that we'll be seeing which of them involves a ketone and which of them does not. Okay. So first of all, let us look into pinnacle rearrangement. Okay, so so firstly we'll be discussing option A. So in pinnacle rearrangement, what we require in the start in the beginning is a pinnacle type of structure. Now, what is a pinnacle? Let me draw the structure pinnacle for you. So OH, OH, methyl, 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 methyl. This molecule is named as pinnacle. Okay, so you require either this structure or structure related to this, that is two OH must be there in adjacent carbons for pinnacle arrangement to occur. Okay, so obviously this reaction is named after only this compound, but it may occur in other such corresponding compounds also. Okay, so what we'll be doing is firstly we'll be putting H plus. This OH lone pair lone pair of O will be attacking this, and OH2 would be formed. Um, so Me. So here OH2 would be formed, and here OH will be there as it is. Now, what would happen is one of the methyls from the adjacent carbon would migrate over here, and this OH2 be released as it is a good living room. Okay, so H2 would be released from the system, and we'll be getting OH. We have methyl over here. We have a plus charge over here, and Me, Me, Me. Okay, so this system is formed. Now what happens is this, as the H is taken from the system as a catalyst, so it needs to be removed from the system. So this H will leave as H plus, giving its lone pair to the oxygen, and then a bond will be formed over here. Okay, so the compound that will be formed is double bond O, Me, and 1 2 3 Me, Me. This compound is named as pinnacle. So you can see that in pinnacle arrangement, the only substrate that we require is pinnacle, and the only catalyst that we require is an acid or H3O plus, we may say. Okay, so obviously this won't be then the correct answer because no ketone is involved in this case. Okay, so let us move on to the next mechanism. Let me change the color. Yeah. So the option B has Hoffman arrangement. You may scroll by go back to the video and see. Okay, so let us see the mechanism of Hoffman arrangement. Okay, so I'll be taking a an arbitrary alkyl group, you may take any such examples for that purpose. Okay, so we have an amide, an alkyl amide. Okay, we will be giving OH minus, and what we will be getting is um, this H would be taken out from the system. Okay, forming a negative charge over here. So minus H2 will be there. Okay, and obviously this negative charge won't be like standing on the H atom. It will an atom. It will be going in resonance to form an N oxide type of ion. Okay, so NH double bond. Here we have O minus. Okay, now in the system Br2 is given. Okay, so instead of Br2, let me write Br bond Br. Okay, so this bond will fall over here, and this bond will take up one Br, removing one Br minus from the system. Okay, so the compound that will be forming is NH Br, and here will be the double bond O. Okay, again the same mechanism followed. This H is there in the system. Now OH minus will be as it is present in the system. We have given sodium hydroxide as the catalyst. Okay, so this would attack over here. This would fall over here, and an oxide of an ion would be formed. Okay, so N Br, and here O minus is present. Okay, then what would happen is this, as this O minus falls over here, this R group will migrate over here and release the Br atom. Okay, so we'll be removing the Br as Br minus, and the compound that we'll be forming is R C. I'm sorry, not C. R N double bond C double bond O. Now this compound is known as, the name of this compound is isocyanate. Okay, and obviously as OH minus is present in the system along with water, so instant hydrolysis will be taking place. Hydrolysis will, so for firstly forming carbamic acid, NHR double bond O. The name is carbamic acid, and then instantly again what will be provided. So we will be getting CO2 plus RNH2. Okay, and amine would be formed. So in this case also you can see that many reagents are taken. That is firstly Br2 is taken, Br2 is a reagent. Then we have NaOH is given as a reagent. Water is also taking part in the reaction. So all of these things are there. So we are not concerned about reagents, but the only substrate that we have taken in the in the beginning, that is amide. Okay, so this is also not a ketone. So this won't be the option correct answer even. Okay, moving on to the next reaction, we have Wolff rearrangement. Okay, so yeah, so Wolff rearrangement, option C. So for Wolff rearrangement, let me write down the mechanism. We'll be taking an acyl chloride for this case. Okay, and acyl chloride. Then we'll be giving CH2N2, that is diazomethane, minus this one is plus. Okay, so this would be attacking over here. This bond will open up, this will fall down, and this Cl minus will be removed. Okay, so we will be getting R C double bond O N triple bond N plus, and here 2 H is there. Okay, now another diazomethane molecule will be coming. Okay, and taking up this H from the system, being released as C3 and triple bond N. Okay, and this minus charge would be like obviously this minus charge won't be staying over here. It will be forming the normal N oxide type of ion. Okay, so we will be taking R C O minus. We have double bond over here. We have N. We have triple bond N. Okay, so this kind of species would be formed. Now, what would happen is this N2 will be released from the system. Okay, this yeah, so this minus charge will be falling over here, this minus charge will be going over here, and this N2 will be released from the system, forming a special species known as a carbene. Okay, what is carbene? I won't be discussing in this video because it is a very huge concept and would be requiring a lot of time. So discussing that when we are solving a question related to carbene as such. Okay, this is a question of mechanisms, so we'll be sticking to that. Okay, so C double bond O CH. Okay, now what would happen is this carbene, what electrons would go over here, and then this R would be migrating and attaching to this cover. Okay, so we'll be getting ketene type of structure. Okay, so R C H double bond C double bond O. This structure is known as a ketene. Okay, now hydrolysis here cannot take place because we are hardly providing any type of material for hydrolysis to occur, that is any base is not given, neither any acid is given. Okay, so obviously you can see only reagent is thiazomethane and only substrate that we are taking is acyl chloride. Okay, so this option is also not correct, implying that option D would be correct, but let us check it out. Okay, so the last option, that is option D, and it was given as bare vinegar oxidation. So for bare vinegar oxidation, we require any type of ketone, which is the which implies that it is the correct option, but still I will be writing down the mechanism. So it requires any type of ketone, and that ketone undergoes rearrangement. Okay, so let us say we have we'll be taking with the smallest possible example, that is acetone. Okay, in acetone we give MCBPA. Sorry, MCBA, that is metachloroperbenzoic acid. Okay, so it is a perbenzoic acid, so it will be furnishing one oxygen in the system. Okay, so we will be having this kind of species. Okay, now what would happen is so basically this would be the actual product. So let me firstly write down the mechanism, and then we'll be discussing the products. Okay, so firstly let us say we took a perbenzoic acid per acetic acid. So let us say we took this one. So H is there, O is there, O, C double bond O, CH3. This is per acetic acid. You may use it in place of perbenzoic acid. So firstly this proton be acidified with the with this H, and here a minus charge would be formed. Okay, so we'll be getting CH3 C plus we have OH, and then we have CH3. Okay, then what will be happening is this minus charge that was formed, O C double bond O CH3, this minus charge would be directly attacking over here. Okay, so we'll be getting CH3 C OH CH3, and then we have O, we have C double bond O and CH3. Okay, then what would happen is this methyl would migrate over here. Okay, and this bond will be open, and obviously this OH would be released from the system, giving releasing H plus. Okay, so then we'll be getting C double bond O CH3 on one side. Okay, and then on the other side we'll be getting OCH3, plus the byproduct will be CH3 C double bond OH. Okay, O minus is there, but this H plus attaches to the O minus, giving us OH acid. Okay, so if we took benzoic acid, we'll be getting benzoic acid as the product. Okay, so you can see that from ketone we have formed methyl ethanoate. Okay, so obviously option D would be the correct option, because uh, ketone is taken as a ketone type of molecule is taken as a substrate of this reaction, and the only reagent that is required is per acid. Okay. for organic acid which has a peroxide linkage, that kind of group will be used as a reagent over here. Okay, so this was all about this video. So let us end this video here. We'll be it was quite long video, and good question this was, which we discussed four mechanisms in a single video. Okay, so let us end this video here. I guess we'll be starting from question number 3 in the next video. So